Welcome students. Today we are going to study cone and its volume from grade 10 mathematics. Okay, all of you know these shapes are called cones. So you like ice cream? Yes, certainly you like. And how much ice cream can be put in this ice cream cone? That is related with volume of the cone, isn't it? Yes. Okay. So before we start formula on volume, let's review a little about the parts and relations of the cone. So here we have got relation between H, R and L, and then lateral surface area, or you can say it curved surface area also, and base area. Okay, first of all, this is the relation between H, R and L. H is main height, R is base radius, and L is slant height. So this relation relates H, R and L such that if you know two of them, you can find third one easily. If you know R and L, you can find H. If you know H and R, you can find L. If you know H and L, you can find R. Then after, next one is lateral surface area. It's pi RL. Formula is pi RL. We need R and L to calculate lateral surface area of cone. This can also be called as curved surface area because the lateral surface is curved. Okay. And then this one is base area. All of you know it is a circle and its formula is pi r square. And total surface area, it was discussed in previous class. Total surface area is pi r L plus R. Okay. Okay, students. Now, let's see one more concept here, that the arc length of the lateral surface area exactly fits to the circumference of the base circle. So sometimes we have to use this relation also to solve problems on cone. Okay. Now let's discuss on volume of cylinder. First of all, cylinder. So all of you know the cylinder is a prism, a circular prism, yes, and its volume can be given as base area times height. So what about its base now? As a cylinder is a circular prism, it has base circle. Yes. So area of the base circle or base area of prism is again pi r square. And if you combine these, or if you substitute value of A as pi r square in this equation, now you are getting the formula for volume of a cylinder. Yes, a cylinder like this. This is a cylinder. This also is a cylinder. Now our topic is on cones. So like this is a cone, and this also is a cone. Now we are going to perform a small experiment that relates volume of this cone and this cylinder. Okay. And as we know the volume of cylinder, it will help us to find volume of cone. First of all, let's check their height. I've taken both of the objects of same height and same base area. It fits here, or I can show here. I'll put a scale over here. You can see. Can you see? Yes, they both are of equal height. Yes. And similarly, if I put it here, the base of cone and base of cylinder exactly fits. I can put it like this way also. Here you can see it fits exactly. Okay, so these two are objects which have same base and same height. Okay, now I'm going to pour something on this cone, this red lentil. So this cone is now full of red lentil. Okay, now you can see this cone is full of red lentil now. So I'm going to pour this in the cylinder. So once again, I'm taking here. This is second cup of cone. Okay, this is second cup of cone full of red lentils, and I'm going to pour it again here. So I'm going to collect this spill out also so that we can calculate more precisely. And now this is third cup of cone filled again. Here you can see and pouring here. Okay, so we have collected all the spill outs also. So what you have concluded out of this experiment? So I've taken 3 cone full of the red lentils into the cylinder. Yes. Now it's exactly full. Out of these 3 cones, it was full. So what do you conclude? Yes. 3 times volume of the cone, 3 times volume of the cone is equal to volume of this cylinder. And we have taken same base and same height. Yes. So, can we conclude like this now? This 3 times cone equals to cylinder in case of volume? Yes. So, if you write V for the volume of the cone, it will be V plus again V plus again V equals to pi r square h. This is the formula for the cylinder of radius r and height h. Yes. So, these 3V makes now 3V equals to pi r square h. As we have all the radius same, height also same, we can say these are height of cone also now. These radius are also of cone. That's why we find out the formula for volume of a cone is 1/3. This 3 goes to divide this side. That's why we write this 1/3. So volume of the cone equals to 1/3 pi r square h. Or we can write this way also. V equals to 1/3 area times height. So what does this A means? Yes, it is base area. So if you know the base area first, you don't need to find radius. Directly you can write base area times height and divide it by 3 to get the volume of the cone. Or if you relate the volume of the cone and volume of the cylinder directly, it will be now volume of cone equals to volume of cylinder divided by 3. Because we have seen just before, we have filled up 3 cups, 3 cone cups, and exactly filled into the cylinder. That was of same base and same height. Yes, when the base of the cylinder and base of the cone are exactly same and height also is exactly same, then their relation is 1/3 of cylinder is volume of the cone. Okay, so finally we can conclude this formula for volume of a cone. So if you know the radius of the base and height of the cone, you can find the volume as V equals to 1/3 pi r square h. Similarly, if you know the base area directly, pi r square, instead of writing pi r square, you can write base area A also. So it shortens the formula V equals to 1/3 area times height. Okay, this is the formula for volume of cone. Here I have mentioned R is radius of the cone, H is height of the cone, and A is base circle area. Okay. Now let's take some quiz. Write down the formula for the volume of a cone. Yes, just before we have discussed, you are correct. Your answer is V equals to 1/3 pi r square h. Okay. Next question goes like this. If the base area A of a cone is 15 meters squares, the base area is given here, and height h is 4 centimeters. Height is also given. So what is the volume of the cone? So just before we have discussed a formula which calculates volume out of base area and height. So yes, you are correct. Your answer is 20 centimeter cubes. So how do you find it? V equals to 1/3 area times height, and area is given to be 15 centimeters square, height is given to be 4 centimeters. So first you multiply 15 times 4, it is 60, and then cancel out by 3, you will get 20 centimeter cube. So that is the volume of the cone. So next question, if the slant height L and the radius R of a cone is given, can we find the volume? Yes, exactly, you have correct answer. You can find out the volume, but before we use the formula for volume, as it contains h there, we have to find first h, then only calculate the volume. So we can find the volume out of these two informations, L and R also, but by finding first h. Using the Pythagorean relation between h, L and R, we can find h and hence the volume. Okay, let's move to next question now. If height of a cone is doubled, you are given a cone and you are going to double its height, keeping its radius constant. That means radius will not be changed, only height will be doubled. So how would it affect its volume? Yes, you're right. It will be doubled. Volume will also be doubled. If you double the height, volume also will be doubled. Because let's say initial height is h and new height is 2h, double of h. And then initial volume V1 is 1/3 of pi r square h, and new volume will be, instead of this h, there will be 2h, double of volume. Okay, this h is substituted by 2h here in case of new volume, and then this 2 is taken as coefficient here, and this exactly fits as initial volume. That means V2 equals to 2 times V1. That's why the new volume is double of initial volume. Okay, so we have got another question here. It asks you about volume effect in volume while radius is doubled. It reads as, if radius of a cone is doubled, keeping its height constant. That means you are going to increase the radius, that means base area will also be increased, but height will not be changed here in this case. So how would it affect its volume? So when we double the radius, how would it affect its volume? So what's your answer? Yes, not only double, the volume will be quadrupled. That means it will be 4 times as before. So you have got the correct answer. It will be 4 times. So how we get this? Here we have taken initial radius as r and new radius as 2r. Then initial volume 1/3 of pi r square h. Same formula as before. And new volume, in case of new volume, in place of r, there will be 2r. But that 2r lies inside the bracket of whole square. Yes, a square is there. And that square will ultimately change this 2 as 4. Because 2 square is 4. And all other terms are just copied. And this 2r whole square is 4r square. And we take this 4 as coefficient here, and all other remaining terms exactly fits into the expression of initial volume here. You can see, and that's why we get V2 finally equal to 4 times V1. That means 4 times the initial volume. And this calculation concludes that if you just double the radius of a cone and keeping its height constant, keeping its height unchanged, its volume will be quadrupled. That means it will be 4 times of the initial volume. Okay, let's move to another question. Here, a cylinder and a cone, just as before in our experiment, a cylinder and a cone have equal base area and equal height. If the volume of the cylinder is 150 centimeter cubed, what is the volume of the cone? Yes, you have guessed correct answer, because just before we have did it. The volume of cylinder divided by 3 times is volume of cone. That's why it is 50 cm cube. You've got the correct answer. So its formula is simply volume of cone equals to volume of cylinder divided by 3. Okay. So let's move on to another question. So this is relation between cone, hemisphere and a cylinder having equal base area. Okay. So question reads as, a cone, a hemisphere and a cylinder. So you know all the shapes. A cone is cone, just we are discussing on cone, and cylinder we have already seen here. And what is hemisphere? Yes, it is half of the sphere. So they all have equal base area here. That means they all stand on same circle. And equal height, they all are of same height. So what is the ratio of their volume? This question asks you about their ratio of the volume. So can you guess it? Yeah, this one is a little bit harder. Okay, let's discuss detailedly on this question. First of all, these might be the figures for this cone, the hemisphere, it is here, this side, and cylinder, it came in the middle. Okay. So they all have same height and same base area. So if you take these all in same base, it will seem like this. So here one thing happens here, that height is exactly equal to radius, because you are taking this hemisphere also. So hemisphere's height means it's again radius. Yes, that's why when we take same height for these all three shapes, it means height equals to radius. As they have equal height, height of hemisphere being radius r, this height is radius r. That's why we get h is r, h equals to r. So after knowing this, if you apply formula on volume of cone, which is 1 by 3 pi r square h, you are going to replace this h again as r. Yes, h is written as r here because h is r. And this makes r cubed here. Yes. So I've shaded this one red, yeah? You will find its reason few seconds later. Now it's volume of hemisphere. So what is the formula for volume of sphere? You have guessed correctly. That is 4 by 3 pi r cube. So as volume of sphere is 4 by 3 pi r cube, volume of hemisphere, just half of that. There was 4 by 3, now it is 2 by 3. Yes, volume of hemisphere is 2 by 3 pi r cubed. Okay, and we have got three shapes and two volumes we have calculated, and third volume is of cylinder. So this is the formula for volume of cylinder. V of cylinder equals to pi r square h. Yeah, and the coefficient is 1 there. So for that one, we can replace as 3 by 3. So what I have made here is all have same denominator and same multipliers, pi r cube, and this also, this h being replaced as r, it again gives as r cube, same as here, okay? So here we got 3 here, and again 3 here, and again 3 here, and pi r cube here, pi r cube here, and pi r cube here. So just the different parts, difference is, in case of cone there is 1, in case of hemisphere there is 2, and in case of cylinder there is 3. That's why I have shaded this red. Okay, then if you compare now, the ratio is simply 1 is to 2 is to 3. So the correct answer for this question is, the ratio is 1 is to 2 is to 3. Okay. Okay, now let's move on to some solving problems. So here we have got a problem here to find volume as per the given information, and the information is like this. Height is given. Here height 8 centimeters is given, and diameter 24 centimeters is given. So So how to find the volume? Can we find the volume right out of this information, or some other measurements we have to calculate? Yes, we have to first find radius, and height is there, and that much is sufficient for finding the volume. So we copied here the diameter d equals to 24, and that's why radius equals to 24 divided by 2, and this is 12 centimeters. And height is also copied here, it is 8 centimeters. So after getting r and h, we can use directly the formula for volume, and the volume's formula is 1/3 of pi r square h, and pi is 22 by 7, r is 12 here, and it is squared there, and h is 8 as given. So we calculate all the values. So we multiply all the numerators. This is 22 here, 12 squared is 144, and this is 8, and denominators also we multiply 3 and 7 down here, and then we divide finally to get the answer 1206.86 centimeter cube. Okay, so this is the volume. So next problem we take here. Instead of giving the main height, slant height is given. So can we find volume when the slant height and radius is given like this? Can we find directly? Think of it. Yes, we cannot find directly because we need h, because in formula of volume it is 1/3 of pi r square h. The term h is there, and h is not available here right now, not given here. So first of all we have to calculate h, and only after that we have to apply the formula for volume. Yes. So how can we find h out of r and l? This is r, this is l. Yes, by using the Pythagorean relation between h, l and r. Okay. So we copy down all the given informations like this. Radius is 8, slant height is 17, and volume is asked. So we take the relation from this triangle AOB, which is right angle triangle. H square plus r square equals to l square. And h square, again, we don't know h. R is substituted as 8, L is substituted as 17, as given. Now we put the values. 8 square is 64, 17 square is 289, and take this 64 back here. It will change its sign to negative, and the value we when we subtract, it gives 225, and again we take this square to next side, making it square root, and it gives h equals to square root of 225, which finally gives h value of h as 15 centimeters. Yes. So now h is ready. Only after getting this h we can use formula for volume. And this is how we find volume. It's simple. Just as before, we use the formula 1/3 of pi r square h and substitute all the values, multiply as per their position, numerators to numerator, denominators to denominator, and finally we get the answer. So this is the volume. So we have got another question now. The vertical height of a solid cone is 3 times the diameter of the base. So a condition is given. A vertical height is 3 times the diameter. Find the total surface area if the volume is 54 pi centimeter cube. Here also volume is given in terms of pi. Sometimes it is given in terms of pi. Okay. So no other informations are given here. Just the ratio of height and diameter and then volume. Okay. We start from we just supposed that height of a cone is h. We'll be using this letter for height. you will be using r for radius, okay, and diameter equals to 2r. Then volume is also given here, we just copied here. Now we have written a small calculation here which calculates a relation between h and r as per the given condition. The condition was, according to question, h equals to 3d, 3 times the diameter. So instead of d we write 2r, and then it makes h equals to 6r. That means height is 6 times the radius, and we suppose this as equation number 1. Okay. Now we are going to use this information, volume information. And how to use this information? We have to use again same volume formula. Don't think that we don't have to find volume and why to use formula. We are going to use the value of volume in that same volume formula. Okay. So this is the formula for volume, and in this V side we keep 54 pi, and others we just copied, and pi also I've copied same because we can cancel out here, okay, and r is copied same because we don't know r, and h is copied as 6r here. It is from equation number 1, you can see here. So instead of h we have 6r. So when we multiply r square and r, it will give r cube, and 3 will cancel out 6, giving 2 here, and pi will be cancelled with this pi. Yes, both sides we can cancel, and it gives finally 54, and this 2 is got from this 6 by 3 is 2, and r square is multiplied with r to give r cube. And now this 2 is going to divide this 54, giving this side r cube equals to, this value is 27. Yes. Now we have to take this cube to next side, making cube root. So this is r equals to cube root of 27. So all of you know that 27 can be factorized into 3 times 3 times 3. That means 3 cubed. So finally we get value of r is 3 centimeters. Okay. And as we get r here, now we can get h also here, because there is relation, h equals to 6r, and when you substitute r as 3, it is 18 centimeters. Okay. So now we got h and r both are ready here. So after finding h, now we have to find, as per the question, we need to find total surface area, but we don't have L right here. There is a term L in total surface area formula. Do you know that formula? Yes, it is pi r L plus r. Yes, L is there. So without finding L, we cannot find total surface area. So before we find total surface area, we have to find L by using the triangle AOB. Yes, there is a Pythagorean relation between H, R and L. So H is 18, R is 3, L is L. Okay, so we substitute the values. 18 square is 324, 3 square is 9, L square is L square. When added, it gives 333, and we are going to take this square to next side to make it root under 333, which gives L equals to 18.25 centimeter. It is approximated in up to second decimal digit. Okay. So now we have got L, we have got R, and now we are ready to find value of total surface area by using this formula. TSA equals to pi r, r plus L. So when substituted, pi is 22 by 7, r is 3, R is again 3 here. So L is 18.25. So this is found here. And we first add them. It gives 21.25, and that will multiply to 3 and 22. All these are numerators, and divided by denominator 7, giving the final answer 200.36 centimeters square. Yes, okay, this is the answer. Okay, now we have got another problem. Here's a cone-shaped pot filled with water. The height of the pot is 21 centimeter and the diameter of its base is 14 centimeters. Here water is filled in this, diameter is given, height is given. And when two solid cones, these small cones with equal dimensions, they both are equal in dimensions, are immersed into the pot, they are dipped into the pot, and 1/3 of water flows outside. So because of this immersing or this dipping, some water is spilled out here, and that spilled water is actually 1/3 of the volume of the cone. That means it is V/3. Flows from outside from the pot. If so, what is the volume of each cone immersed in the pot? Okay, so we have to find the volume of this small cone. So as per this question, first we copy height and diameter, and then as we know the diameter, we can find the radius by dividing it by 2, it is 7. Okay, now we suppose volume of water in the conical pot, this big conical pot is to be capital V, and volume of the small cone, these cones, to be small v. Okay, this is capital V and this is small v. As immersing of two small cones, while we dip in these two small cones equal volumes into the pot, makes 1/3 of the volume of the water spilled out. That means accordingly 2 times this volume is exactly same as the spilled amount of water, that is 1/3 of V. This V/3 and 1/3 of V, same thing. So this 2V, that means volume of small cones, equals to 1/3 of total big cone volume B. Okay, so we substitute the values, and you don't need to substitute the formula for a small v because we need V directly. Yeah, we need volume of small cone. Okay, then this 1/3 is 1/3 copied here, right here, and instead of V, we have applied formula this much, 1/3 of pi r square h. Yes, then we substitute all the values also. R square is 7 square here, h is 21, and these two threes are multiplied to get 9 here, and pi is 22/7. Yes. So after calculation, the calculation is much simpler. Everything is multiply and divide there. First we multiply all the numerators, or you can cancel out there also. 7 is, one of the 7 is cancelled here, and 3 times 7 is cancelled here. So, and 2 comes to divide this side here. So all of you can do this calculation easily, and it is giving you the value of small v to be 179.67 cm cube, and which is required answer. Okay, now I am going to give you some assignments. So first is to find CSA, TSA and V out of this given condition. Condition is radius is given, slant height is given, main height is not given. So how to find, you know it. and its answer. You can pause the screen and copy this to practice. So next question is similar, but here mean height is given and slant height is given, radius is not given. So how to find radius, and then after find all this. Okay, you can copy the answer here and check your solvings. This is third. Here base circumference is given and slant height is given. So on this condition you have to find CSA, TSA and V. So this is the answer. So check your answer here. Okay. Another problem here. R is not given, R is to be found, height is also to be found, but area of triangle AOB is given here. This is a bit different, yeah? So this triangle's area is given. So how to relate that with R and H? Okay. Try this problem. It will involve some algebraic calculation on R and H. Okay, that much is hint for you. And the answer is here. R comes to be 4.2 and H also. TSA also I have given here. So today we have studied volume of cone and its formulae, and we did some problems on volume of cone and its area related with area also, and some relations between H, L and R. So these are the problems we deal with cone's volume and surface area. So we will meet in next class. Thank you.